What is up, everybody? DevCode here, back with another video. So it has been a minute since we last talked, and I'm gonna be honest with you, I kind of missed not doing YouTube videos for such a long time. I was really excited about getting the series going, and then I took like this huge break. So I'm gonna talk about exactly what the hell happened, why I took a break, and trust me, I hope by the end of this video, you will have found that it's well worth it. So I'm not going to waste any time. Let's just get right into it. Alright, so let's jump right into it. So as you can see here, you can kind of get what I've been doing for such a long time just by looking at the screen. I've mostly been focusing on architecture, reliability, and speed. So in short, the TDLR version of this video, I'm going to try to not keep it too long, but basically what I've done has I've made the language faster, I've made the language more reliable, and I've greatly improved the architecture of how the language is built, as well as the architecture it runs on, and all of that. So basically, at this point, I want to build kind of like the language of the future. This is kind of my goal. I don't know how the hell I'm going to get there. I definitely want a lot of people to use this language eventually, um, but there's going to be a lot of edits and updates that I'm going to have to do to get it to that point. All right, so what have I been up to? I've been focusing on building a better language. So I did a ton of research and development. I was very unhappy with the state of the language, guys. Like, to be honest, that was like the main reason why I stopped doing the series because I started it and I just I wasn't really satisfied with what I was showing you guys. And I didn't want to show you shit build of the language. Like I didn't want to show you how to build a shitty compiler because I would have like made tons of changes and it would have made all of my videos null and void. So I just decided, why don't I just fix it now and then show you guys the result later? A 200 plus improvement in performance and over 200% improvement. That is the big thing that I'm really excited to talk to you guys about how the hell I did that. But the language is fast. Believe me, it's really fast. It was very slow before, and you'll see how fast it's gotten. It's still pretty slow based on industry standards, but I think at this point and where I'm at with my language, it's fast enough to where I'm proud enough to show you guys how to build a quick language that definitely outpaced Python. Before this, though, before the performance gains, it was slower than Python. So just to give you an idea. New JIT compiler system. Not going to talk about that right now. I think I have a slide later on. We'll get into that. But that's basically how I sped up the majority of the language. Basically, that's how I got the performance increase. New goals for the language. So I got tons of new goals for the language. We're going to get into that in this video. That's another reason why I think that I've really been improving as a developer and as a language developer and just overall. So we'll get into that. Tons of bug fixes came with this major update in the past year, as well as I started rewriting the compiler. So before I was kind of showing you guys the compiler, but it was already built, and I was just kind of like copying and pasting what I've already done. But this time, you guys are actually going to see me building the compiler live. So that's going to be really cool. But yeah, the compiler isn't currently done yet. I'm still working on it. So next, we have redesigned the grammar and syntax model. This part was hard as hell to do because redesigning a language is not easy, especially when you have a, I don't want to say proven system, but like when you have a system built already and you're expecting certain things, you're expecting things to be a certain way, it's not easy. But we'll get into that as well. So let's talk about my development timeline. What kind of have I been up to? And this is the development timeline for 2019. So this is all of 2019, kind of what I've been up to in the past year while I wasn't filming YouTube videos. And I thought it was kind of interesting, kind of looking back on what I've done in a year or two. So, I started out, I took a little hiatus. I think that really helps me, like when I take huge breaks like that. programming on the language, it helps a ton. I come back with tons of new ideas. I started research and development in around May to July, basically summertime of last year, and I started improving the performance of the language. So that was when I did the bulk of my research about language design, and just a ton of other different things, which we will get into later. Between August and October, kind of like end of the summer, I was basically just kind of updating the runtime system, and you can see like it says JIT 2.0 development, and basically what that means is, so I wrote a JIT system between like in the beginning of the summer, between May to July. It was trash. So I wrote it again, and I rewrote it from the ground up, and it is so clean. The code is really nice. So I cannot wait to show you guys that. But yeah, that's just kind of why I put 2.0. Currently, though, the JIT unfortunately only runs on 64-bit Windows Intel chips. It can run on others. It's not really built for other CPUs right now. It's very sketchy. So, but it's proven to work on 64-bit Windows Intel chips. So that's like if the computer has that chip inside of it, like the language will run at its absolute fastest. Um, and basically from like the end of last year to now, I'm basically just doing compiler 2.0, rewriting it, doing syntax redesign, fixing major bugs between both the runtime system and the actual compiler. So let's talk about my new goals. Since like, the redesign of the language of last year, I've grown so much. I'm not even just talking about the actual language development. Like I've grown as a developer. As you guys know, I'm an Android developer in my profession. That's my actual profession, and sometimes I try to do like back-end server development too as well, but I usually try to just stick to Android. But yeah, so I've grown a ton, which has, in that growth, made me realize that goals are important for anything. And I know that sounds kind of stupid. Like, what do you mean? Before, to be honest, people would always ask me about my language, and I would have no idea how to answer them. Like, they would say, "Well, what's the purpose of your language? Why choose your language over other languages? What things does it have to offer?" And I would usually have a few canned responses, but when they really got down and dirty into asking me specific questions, I wouldn't really have an answer. So I created these goals to help me get to that point, basically. So I'm focusing on like three main pillars, which are going to be reliability, architecture, and experience, which is a little different than what you saw on the other one, but uh, they're around the same thing. I think experience goes hand in hand with speed and reliability. If you have like a language that's really fast, your experience with it is going to be really good because it's fast. You're not waiting for it to execute your program for ages. Okay, so also like with those goals too, it also brings some new goals to this channel, right? So not only is this video kind of about an update of what I've been doing for the past year, it's kind of also a channels update too. I'm going to change some things around. So with that comes new changes to the channel, which are I'm going to start to do much smaller videos. I'm going to be more concise, more to the point. I think sometimes I explain a little bit too much. I don't know. Tell me if I'm wrong, guys. But basically, I want to have smaller chunk videos. That way, I'm not filming a video for like 3 hours and I edit it down to like 2 hours, or I edit a 2 hour video down to like 1 hour. It's a pain in the ass for me. Plus, like, I get to focus a bit more on things that matter, right? I get to like break it up. So if you're actually trying to like build a programming language, maybe you don't want to surf through 100 videos that are each an hour long to find that 5 minutes of that one thing that you were trying to do as you were trying to build your programming language. So I want it to be where you can just like look through my video library, see the exact thing that you want to do, and then just watch that video. So I'm gonna try to keep my videos from after this video on forward, like no more than like 15 minutes. I'm gonna be honest, guys. So maybe with that, I film maybe twice a week. But at the least, I know that I'm gonna be doing about one video a week every single month. As to before, I think I was doing like one or two videos a month, which is bad. So yeah. Um, yeah, so all right, so let's talk about the syntax design. talk is cheap, show me the code, guys, right? Like I know you guys are interested in kind of seeing like what I've been up to, and what kind of true changes have I made in the language besides the performance. So I've done a ton of research in terms of like not just the architecture of building a language and not just like making a language reliable, but I've also done a lot of research looking at other languages and seeing what developers like in those languages. Why do they like those languages? What makes them so special? So that's kind of what came up to this point to where I have these new ideas and I have all these changes. And I put them in a list here because I'm just going to show you guys. So yeah, let's get into it. So first, true lambdas. Oh, and by the way, really quick side note, these aren't going to be the final features of the language, nor are these features finalized in terms of like their look. So don't like if something looks ugly or weird, don't worry about it. It's not a final thing. But for the purpose of this YouTube series and to keep things concise, I'm going to try to keep things pretty consistent. I don't want to be changing things too much under you guys' feet. So, yeah. All right, so let's look at true lambdas. So I'm going to go here and also, if you guys are wondering, so the IDE I'm using, I think I said it before, but it's C-Line. You guys got to download this. If you guys want to build a programming language, especially using C++, you have to download this IDE. It is the best IDE I've ever used, and they've made tons of updates that just make it brilliant. So definitely check that out. All right, so I'm gonna go here. I'm gonna create a new sharp file. Don't worry if this looks kind of cool and you're like, how did I do that? I'm gonna get into that a little bit later. So let's call this main, or let's call it demo, and then module app. I finally know. All right, so we're gonna define a main. So because I'm writing the compiler over again, I can't show you the actual output of this code because it's not finished. So I'm just going to be able to show you guys like how it looks, and then eventually later on the YouTube series, we'll be able to see these things actually put into action and actually running on the language itself. So true lambdas. All right. So before I'm going to kind of do like a compare and contrast. So before we kind of had this was like the syntax for building a function pointer, right? So let's say we had some class, right? So let's say we have a class list of t, and list had a, let's see, here, sort. So let's say we had a class called list, and it had a function called linear sort. So sort, and that took a function as a parameter, sort function, and then that parameter, I don't know, had t of data p1, t of p2, and it returned a var. Yeah, that's good. All right, so I'm not going to put in the implementation details, but let's just say that we had like a linear sort function, right? And that took a function parameter as an argument, or a function pointer as an argument. And you basically just tell the user, hey, I'm going to pass you two elements in the list, and you tell me whether or not they should be swapped, basically. And so before we would have to do like sort function var p1, var p2, var is equal to define var p1, var p2. I'm already starting to get annoyed, and you can see why I started to add lambdas, because I've been doing a lot in the language. Like I've been using the features in the language a lot, and this becomes a huge pain in the ass to do. So let's create all right, so create a list of var, and again, this is the old way. I'm doing a lot of crap that it doesn't look like this, so I actually should have wrote it in the new syntax, but it's fine. All right, so list is equal to list of var. All right, so now if we say list dot linear sort, and we pass in the sort function, boom, we're done, right? And that's all we had to do. Now we didn't have to create this variable. This is like only used for if you want to reuse it, but I just want to be concise, or I want us to be comprehensive and show you guys the full thing. What you'd most likely do is take out this code here, and you would have a, so this functionality was not in the language a year ago, right? So what this is this is basically an anonymous function, right? So you have your function declaration here. This is how you define a function in a global scope. This is how you define it in a class scope. And this was basically an anonymous function defined inside of whatever scope you want it to be. So that is new, something I added. I don't know why I didn't put that in the list. That's kind of weird, but um, I was doing this for about 6 months and I got pissed off because it's too much typing. So basically now all you have to do is this. Um, P1. As you can kind of see here, it's a lot simpler. It's a lot cleaner. Basically, all you have to do is just type linear sort. This is a true lambda, right? You say here are my parameters, and here are the names for the parameters. Here's the freaking code, and you just return whatever whatever you want to return, right? So um, what this is going to do is it's basically just going to swap everything, right? So you're not really sorting, but yeah, so this is like true lambdas, and yeah, I don't want to get into it. I don't want to get too much into it, but just know like you can create functions, inline anonymous functions a lot easier. Multiple module imports. So let's go back here. All right, so before it was really dumb. I got sick of this too. You had to do like st.io, then you had to do import st.thread. I think, did you have to do? I don't think so. But you get the point, right? You have to type all of this stuff out. I don't remember the actual library names. But now all I can do, or all you have to do, is just do st.everything, and basically you just import everything in the standard library. That was a pretty easy fix, and I'm surprised I didn't have this before, but yeah, that's all it is. So let's move on. Variable declaration format. All right, so I guess if I had showed you before, it would have given it away. So let's remove this linear sort code. So you can see here, this is the old way to declare variables. New way is this, right? So before you'd have to create like a var, call it num, and set that equal to 9, right? Now you don't have to do that. You just say num is equal to 9. And it figures it out. So what this is this is type inference. Oh shit, I actually think I'm getting ahead of myself here. Okay, so ignore that. Here's a new format for creating a var, right? So you basically have the name of your variable, this thingy, and then the type of whatever data set, and then your value, right? So it's the same thing for classes. So you'd have your x is equal to var, right? And you have y is equal to another var, or you could just say x, y, right? And they're both equal to vars. And then you could even go even further and say x is equal to 1, y is equal to 2. Right, so they're both vars, and then yeah. So that's basically the new syntax. It's really clean, it's really nice. I like it because it flows with you, right? So you type your what is the name of your variable, and then you type the type, and then you just type the value. So I like this, it's much nicer. Yeah, that's the new syntax. Same thing with new. So like if we wanted to, let's transpose this into the new way. List is equal to, yeah, I'm just gonna do it. All right, I'll explain what this means. List type var. Um, okay, so that's the new way. You just create your list and you set it to whatever the hell you want, and then you can do a linear sort on it. This language is still more object-oriented focused, but I'm allowing for you to be a little bit more expressive, if that's the right word. Not exactly sure. Um, yeah, it's just a lot cleaner, so I like it. Next is type reference. All right, so you've kind of already seen that. So basically, the format of my language is you have two main ways of, you know, declaring something, right? So you have your this and your type, right? Or you have this, which means infer the type, and then you have your expression, and it basically infers the type from this expression because every expression has a final type that it evaluates to. So that's basically the idea behind it. And my God, guys, you have no idea how difficult that shit was. Like building a programming language to just say like x is equal to 9. I know it seems trivial, but there's so much that goes into making this work. It's crazy. You'll see though later on the episode series. All right, let's go to the next one. Type inference. Okay, inline methods. So this is another one. This is a feature that I stole from another language. Um, so yeah, all right. So here's a better idea. So let's say we have our list, right? And it's a var. And let's say we have our function called size, right? Because you want to get the size of the function. Previously, what you had to do is you had to say like var, and you can still do this, by the way. You can say var, and then you can say return size. All right, I butchered that, but you get the idea. Now you don't have to do that. You can just say var is equal to size. So it's a lot easier. This is more for like simple things, like simple line comments. I really like this because like it doesn't force you to have to like constantly write all this boilerplate code. And again, remember, in my language, I have two concepts, right? So I have a concept of a typed assignment and inferred type assignment. So you actually don't even have to do this. You can just do that. And the compiler will figure out what size returns based on the expression to the right side of it. So and this is why I'm like so excited to like show you guys everything that I've done. So all of these features that you're seeing today in the presentation, with the exception of I think like one, maybe two, everything's already implemented. So you guys are going to see firsthand how big languages like Java, Kotlin, C++ do all of these features at a high level to make like programming a lot easier for developers. So definitely excited about that. All right, next is anonymous arrays. So let's do that. So I'm going to remove some of this code here. Okay, so previously the way you had to do is you had to say var, let's say I array, to an array, is equal to new var array, and you had to do this shit. So you had to say 1, 2, 3, and that would basically create like an integer array for you. This is a lot of boilerplate code. It's very annoying. So when you bunch everything together, right? So when you put together type inference, the new syntax of creating a variable, and then this new thing which is called what did I call it? Anonymous arrays. Um, you can see how beautiful it is. So we're gonna say I array is equal to 1, 2, 3. All right, so basically what it does is the compiler says, all right, here's an array. Let me figure out what the type of the first element is and make sure that every subsequent type matches the first type. That's literally all it's doing. Because before what my compiler was very verbose. You had to like tell it exactly what you were processing. So I moved more towards like a magical compiler, which it sounds funny, but it's true. Like my compiler does a lot of magic behind the scenes to like figure out all these types, make sure they're together. It's really nice. So this is a very fast and clean way to like make an array, and it's very easy, right? Like you know what this is. It's an array of numbers, right? Why should you have to type all this extra crap? Um, so there's that. For loops, I'm gonna brush up on this one really quick because I this one's honestly, to be honest, not really finalized. I haven't even now. This is one of those features that isn't implemented. I'm still like deciding on what the hell to do. So this is my proposed like syntax for a for loop. So before you had to do for var I is equal to 0 as less than, I don't know, let's say 10. And then you had to do your code in here, right? So yeah, put your code in there. So my proposed syntax for this is to say like for less than 10, and then you just put your code in there. It's a lot faster. Like you saw how fast I type this versus typing all this crap. Because you have to remember all this stuff, right? If you literally just want to do something for an X amount of time and you don't want to care about like tracking the variable, like then what's the point? Like, like what's the point of doing that? Um Now I'm sure you're gonna ask like, all right, well, what if you have like print line, um, I is equal to plus I, right? Well, how do you get the I? I'm still figuring that out. I think I think it's gonna be called it. Probably, I have no idea. So again, this is still in the works, but basically I'm looking for a way to like shorten for loops. All right, so yeah, that I don't really have much else to say about for loops. I'm still thinking about exactly what the hell I'm gonna do, so don't pay too much attention to this because it might not even look like this in like a couple of months. So yeah, but I just wanted to share that with you guys. All right, let's keep going. Dynamic strings. All right, so this one I freaking love. So let's just copy this. Let's remove this code. All right, so we have this. I mean, you can still do this in the language, right? Like this is a very verbose for loop. You'll still be able to do it this way, but there are like faster ways to do it, basically, is what I'm getting at. So before you kind of had to do like this. You had to say, I is equal to I, right? So you print out I, it prints it out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't have to do that anymore. You just say, what is it? Is it $I? Right? So you say I is $I, the compiler resolves it as I. It's built into the string. This is actually stolen from another language. I'll admit it was stolen from Kotlin, but I don't know. I think it's really nice. I think it's really cool. And you get to go a step further as well. So like let's say let's create a variable here. So let's create a new list. List is equal to list of type var. Yeah, okay, so we have our list, right? Let's say we wanted to print out the list of size. You can do this, list dot size. You can literally write expressions directly into a string. Like, so list size is, and you can literally write this expression into a string. Out of everything that I've showed you guys today, this was by far the easiest to do. Like, this was the easiest feature to implement in the language, which is very weird. And actually, I think this, when we start up the YouTube series or when I start doing the regularly scheduled programming, this is the first thing you guys are actually going to learn how to do in the language. And it's like super easy. So definitely look out for that. Pretty sure that's going to be like the next couple of episodes or so. All right. So that is dynamic strings. Okay. Next, extension classes. All right, so believe it or not, all right, so let's say so let's create a class array list of type T and to have a base class of list of type T. Okay, so believe it or not, so like okay, so in Java, right? You have a class, you can have like an abstract class. You can have an abstract class, and that abstract class has some, all right, so you have like an abstract void of foo, and it does something, right? Well, uh, in Sharp, I haven't really had that feature to be able to do that. I had a pseudo feature, so I basically have like delegates, foo. So I have delegates and delegates in Sharp. Oh, this is a new thing. Why the hell didn't I add that? Okay, I don't know why I didn't add that. All right, so all right, so I'm going to explain two things in one. All right, so first, basically, I have a concept of delegates in Sharp, and that's kind of like half-ass like doing abstract, but not really. Mainly, delegates are used for interfaces. So, like, uh, if we create an interface here called changed, and in there we would have to define a delegate. On change listener actually would be an actual. All right, so delegate unchanged. So we would define a delegate in here. And what delegates are basically, they're a function that delegates a task to another object, right? They're basically like functions that it forces you to implement them, right? So we would say on change listener here, right? So we would have to implement this on change function. If we didn't, the compiler would crash because delegate has no subscribers. So in this class represents ArrayList represents the subscriber, which subscribes to the onChange function because it's using this class and then it does the work in there. right? So do work. So that was kind of the half-assed approach I have, but now I have a concept called extension classes. So if you have extension class, basically what an extension class is, it's a class that cannot be instantiated, right? So interfaces are extension classes by default. You can't instantiate interfaces. Before you used to be able to do that, which makes no fucking sense. But now, basically, if I try to do like new list of var, the compiler wouldn't let me because what it's saying is this class needs to be extended by another class in order to be instantiated. So I wouldn't be able to do list, but I can do array list, right? So I can do that, but I won't be able to do list. And it's basically the same thing as abstract, but in my personal opinion, this is my personal opinion. I'm not attacking anybody who likes Java, but I think the word abstract is a very stupid way to explain. I get it. It's explaining that it's abstraction, and that's effectively what the extension keyword is doing. It's abstracting the class to be, it's forcing you to abstract the class basically. But I think that extension is a better word for it because what you're saying is I want this class to be extended, or I want to, you get the point. Yeah, I'm not gonna keep rambling on, but yeah, so I chose extension as the keyword for it, and yeah, that's it. All right, so yep, I added delegate functions and extension classes. This language is really starting to get complicated, so if you guys don't understand what the hell any of this means, I would definitely say do some research on like Java, learn object-oriented programming, because if you don't understand object-oriented programming, all of this is going to be very confusing to you. So, and I just don't have like, there's plenty of tutorials out there explaining object-oriented programming, so definitely check that out. All right, for the final thing, the piece de resistance, object and class mutation. All right, so I actually, as of time of recording this video, I just finished this feature yesterday in the compiler, and it's badass. So let's just jump right into it. So, damn, what is it? Okay, so why did I do that? Okay, so I'm gonna bring back list here, and I'm gonna delete everything else. All right, so we have our list, right? So we have our list class. Let's create this again. List is equal to this value. All right, um, okay, so there's two parts to this, right? I'm gonna pick the easier part first, so I don't break you guys' brains. So the first part is what's called extension functions. This is yet another feature I stole from Kotlin. So it's really nice. Basically, what an extension function is right. Let's say you have like a list, right, and you want to do something. I don't know. Let's think what's something you'd want to do on a list. Um, okay, let's say like get last element, right? So our list is gonna have a data set um, of type T, right? So our class is gonna have a data set of type T, right? Or the array that it's managing internal. But this is most likely gonna be private, right? It's not gonna let you access this data set. Same thing with size, right? Variables are private by default too, by the way. You don't have to do this, but I'm just being comprehensive. So let's say we want to do list dot, I don't know, last element, right? Let's say we want to get the last element, and let's say oops, last num is equal to this, right? And we want to do this. Well, we don't have this function, and you saw like when I was typing out the IDE didn't find that function. So because like what you'd originally have to do, or what you would have to probably do, is you'd have to usually have to create like a class called array list, and you'd have to have it a type T, and you'd have to base list base the list from type T, and then you'd have to have your last element function, um, and you'd return a var. I'm not even gonna type it the old way. Is equal to, yeah, I'm not even gonna do that. Var is equal to data at size minus Yeah. So this is what you'd have to do before, right? And even with using the new syntax of like having an inline statement, now I wouldn't do this because this would actually crash because data could be null. But you get the point, right? Like you'd have to do all this boilerplate crap, which is not good. Now you can just literally say define list of type var dot last element, oops, and return data at size -1. And that's it. So basically an extension function, what this does is this effectively creates this function inside of this class without having to do all that abstraction bullshit. So it's really nice. It's a really nice way. Like I can't explain like the technical terms of what an extension function, like I can't get it out of my head to explain like the nitty gritty of like what it actually is. So if you guys are interested in learning about extension functions, read it up. There's a ton of videos on Kotlin explaining extension functions, how they work, why they work. We're gonna get into the mechanics of this anyway later on in the YouTube series, so I'm not gonna speak much on it right now. I just want to put it out there. And now I'm pretty sure some of you guys have questions, right? You're like, okay, well, what happens if I have a, all right, so like let's say we create an enum of, I don't know, color or something, right? And color has red. I'm not even going to set numbers here. I'm just green, blue, right? So what if you have like a colors list and you assign that to new list of color, and right, so if you try to do colors list dot last element, and you try to assign the last color is equal to colors list last element. So if you try to do that, it's not going to work. The compiler is going to stop you at the gates because we're specifying only for the class list of type var. We want to add this function to that class. But if you want to globalize it, right? Like if you for every type of list generic you want to do that, all you have to do is, if you want it to be part of everyone, just do that, right? So list dot element or list dot last element, and basically what that does is for every type of generic class created by class list, it will have that function inside of it. So that's another way you can do that. So that's really cool. All right. So now I'm going to talk about, what did I call it? Class mutations. All right, so this is a very, very complex feature. If I confuse the shit out of you guys, don't worry. It's don't worry if you don't understand it. It's fine. We'll get into it later. But what I'm going to do right now is I'm going to write up a quick program to like explain it, because if I don't, it's not going to make any sense. All right, so we're going to create a REST API. So let's assume that like we have like a server, right? And we want to define some value. Now I don't have annotations in the language yet, so yeah, this is gonna be a little weird, but just picture that it works, right? I'm kind of like half-assing it, but it's fine. Let's say get username. Right, so let's assume we have a REST API that's returning, and if you guys don't understand what that is, if you haven't worked with like server to client, REST APIs or anything like that, don't worry about it. Just assume like this is some type of library that returns this data from a server, okay? And we get back a user serialized from JSON into this format. We have our name, profile user, and our age. So if we wanted to say like user.toString, let's assume that user is a class inside of a library that we can't even touch, right? Like let's say it's some user library written by somebody else. You didn't write it. You're just importing that library and you're importing those classes into your project using Sharp. And it doesn't have a toString function. It might have getters and setters, which I'm not going to write for this. You guys get the point. But it might have getters and setters for like name, profile, and age, but it might not have a toString. So what you'd probably have to do is you'd have to create class user util, right? Which I'm really struggling to explain this to you guys. But trust me, it's a lot cooler than it'll probably seem. It's a little bit anticlimactic, but user util, and let's say define print user. You'd have to do that. User of type user, and oops, you have to have that, and then you put your code in here to like say user dot get name plus user dot blah blah blah. All right, so you get the point. That's what that would do. So originally you'd have to do that, right? And you'd have to say, instead of this, you'd have to say user util dot print user. You'd have to do that, and I'm not gonna, well, so you'd have to do that to actually print out the user. But with this new feature, with again, what is it called? Class mutation, you don't have to do that. What you can do is you can mutate user, and you can write a define delegate to string, and you can literally write your code in here. So you still have to implement the details, right? You still have to say like, name plus profile plus age, but you're effectively writing code inside of the user class as if you were creating the class for the first time. But you're not, you're just adding it, you're mutating it to it. So this might be very confusing to you, this might not be. This is a really cool feature. Because I mean, of course you could argue like, okay, well, why don't you use an extension function, right? So you say define user dot to string. The problem with doing this is toString is a method inside of object. Now this is my I'm rewriting the standard library. It's a bit weird right now, but I don't have everything implemented. But basically, toString is going to be a function written inside the object class, and every class implements object. So you can't create this function using function extensions because it's just not going to work. The compiler's not going to allow you because the function already exists. So instead, we use mutations. Now, this is a bit confusing. So I'm going to do a very quick, simple explanation on what the hell mutations are or what that keyword does. All right, so picture this, right? So picture you, oh, that's a really bad picture. All right, these are not good. Okay, so picture you have like this DNA strand, right? This DNA strand represents back. There we go. All right. So this DNA strand right here represents the user class, right? So the user has DNA. This strand represents name. This strand right here represents profile. And these two strands represent age. And that's the makeup of user. So whenever, typically in object-oriented programming, the way you mutate state is you use some level of abstraction to mutate the state of an object. And you can still do that in Sharp, the language, but you now have a new way of mutating objects without having to create all this boilerplate bullcrap, where you have to like create these extra classes, which sometimes it's very sketchy to do that because you don't really have a good name for the class, because you just wish you could just put the freaking function and functionality inside of the class itself. So what mutate does is it literally injects this code into here, and it doesn't stop there, right? Like, so you saw up here, classes can have base classes of, some class. It can have interfaces of some interface. Um, So mutations don't stop there, right? Not only can you like put in functions, you can add fields. You can add another one. I don't know, let's say height, and let's equal to 9. There are very good use cases for this. I'm not really doing a good job explaining, so I apologize. But you can also add base classes, so you can say some base class. So now this library that was once unchanged by this class in some other library, this class in some other library that was expected to have, these sets of data, these sets of functions, these sets of interfaces maybe that it implements. You can break the rules and you can just say, no, I want it to implement my interface. And there could be a very good use case for that because, like, let's say you have this user class and you want to have a listener, or you want to have some type of like update on that class using a listener structure. You can kind of do it and finagle it that way instead of like creating this weird abstraction of like a higher level user class and having that implemented and doing all this weird stuff. So this somewhat flattens out abstraction to the point to where you can make classes a bit more comprehensive if you want. So I'm gonna get rid of this. So you can basically do everything in mutate as you can do here. Now, I'm sure some of you are wondering, all right, so what happens if I create an API or some library, I don't want the user to do this crap. So there are basically two types. There's stable and then there's unstable classes, right? Stable classes are classes that are basically expected to, once you write the implementation for that class, it cannot be mutated, right? So let's explain what that means. So if I put stable here, right? So this is now a stable class. So I can no longer mutate this class, right? I can no longer mutate user directly. I can mutate it, however, still by doing class my user, right? So I can still do it this way, right? And I can still, put in my function change user, which does some stuff here. And you can like modify the actual fields inside of user. So you can do that still by because I mean that's in every programming language. That's a simple no cost abstraction. But if you don't want the user to be able to completely change what user both inherits as a base class, implements as a listener, has its fields, and has its functions, then you can specify it's a stable. Otherwise, every single class in Sharp is unstable by default. So sorry if I confused you. We will get into this later. This is a very complicated topic. And that was the hardest thing I've ever done in a programming language to get that feature to work. So we'll jump into that a little bit later, but let's go back because I want to finish the presentation. Oops. All right. All right. So that's it. So that's all the syntax design and new, I guess, features that I've added to the language. Now let's jump into the performance gain. So how did I do it? Let's talk about it. All right, so I reduced the memory footprint from 72 bytes down to 40 bytes. That was a big reason why I think Sharp sped up so much. As you can see here, I have an example to kind of show you the magnitude of what that means. So basically, I created a program. I don't remember exactly the structure of it, but I created like a test class and I put strings in there, I put integers, I put other objects in there that held other values, and I basically just made a bloated elephant object. And I created 100 million of those objects, and it took about 2.6 gigabytes to allocate. Now, that's only 100 million objects, right? That's not a lot of objects. Well, it is, but for relative to the amount of memory, it took almost 3 gigs to just do 100 million objects. That's not good. That's terrible. So, and I also knew that was like stunting my performance. So I did tons of research. I really figured it out, and I basically figured out how to scrunch the size of my objects almost in half. So it's almost 3 gigs, and it's like 1.5 times 2 is 3, but you get the point. Like it's not an exact correlation. And these are estimates, like this isn't the exact number. I don't remember what the exact number was. I did this ages ago, but this is approximately what the result was. So for the exact same program, I went from 2.6 gigs to 1.5. That's freaking awesome. Thread local variables. This is something also new. Basically, what a thread local variable is, for every thread that you have, for you guys who don't know, for every thread that you have, you can have a local variable to that so that the thread that owns that variable is the only one who can edit it and no other thread can. That way you don't have to, use mutex locks and stuff. So that was a big performance boost because before I had to do this weird crap where how I was kind of doing thread local variables was very stupid. So it alleviated a lot of boilerplate code and a lot of um, just a lot of weird things in the background that I had to like get thread locals to work. So that was nice. New publishing system for performance and reliability. This one is not really anything dealing with code. What it is basically now every release I am basically forcing myself to test my code. And I know that may sound like, well, you didn't do that before. Yes, I did, but this new publishing system is a lot more comprehensive. Basically, what I do in short is when I'm ready to do the update, I back test. So I test old code, like for instance, because I don't update every month, like or even every week. Like I update in vast distances of time for the language because I do a lot in the between time. And I basically just test, all right, if you wrote some code 3 months ago, does it still work? And then I also test the performance. So did it get slower from the last update? Did it get faster? Like where am I in terms of like the reliability and the speed of the language? So that's definitely helped out a lot for me to realize how slow it is and to improve it and do bug fixes and such. New JIT system, we already talked about that. And there's another slide in the later on in this video that will explain that. Improved instruction execution speed. Basically, what that is so you know how like Java has bytecode. My language also has bytecode because it's a virtual machine. So the compiler generates this bytecode, and it's just fixed, right? So the virtual machine only executes that. It doesn't like edit it, at the runtime. It just executes whatever the compiler gives it. Well, a lot of those bytecode instructions were very like slow. They weren't very quick. So like doing things like casting, switch statements, and I think some other things I don't remember were very slow. So I just sped them up. Basically, is pretty much it. Rewrote critical sections of the standard library. This was important. This actually helped out a lot too. This is more of like a high level change. I basically updated critical sections like strings, integers, and just the way how I process information in the standard library, which helped out a lot in performance. So that was nice. Rewrote the compiler. We already talked about that. Redesigned the grammar syntax model. We also talked about that. So I know you may not think like, oh, redesigning the grammar and syntax model might not have a benefit on performance. It actually does. If you require the user to write less code, like all of those features and stuff that I showed you before, um, a lot of those things were called like zero cost abstractions. So, like you can do some pretty cool stuff without having to write a lot of boilerplate code to do the exact same thing, right? So changes in the syntax actually inherently does speed up the language, which is really nice. So that's kind of why I added it here. Um, but yeah, so what's a JIT compiler? Here's a rough example of what that is. So basically you have your bytecode, which is what this is here, the CIL, and then you have your metadata. So the metadata is what the compiler generates. It tells you here are the classes that I found in the code. Here are the variables. Here are the functions. All that stuff, right? And then you have your JIT compiler. You have your native code, your memory cache, which is a cache of all of the functions that you created at the low level. And then finally, you have your function that you're actually executing, which is foo. So this graph is a little bit weird. My JIT is not exactly in this format. It's very close. That's why I picked this one, but the flow of it is incorrect. So basically, the way my JIT works is you have your bytecode, right? So you can picture this being the interpreter. The interpreter's running, boom, the interpreter hits a call instruction. So what the interpreter does is it says, all right, I'm at the call instruction. Let me ask or let me talk to my JIT. It talks to the JIT. It says, hey, am I ready to, or I want to execute this function, right? JIT says, oh, okay, you want to execute this function. Let me talk to the native code part of my JIT. Basically, what that is that's like the heart of the JIT that keeps track of everything. It keeps track of which functions are the native code basically holds like your memory cache. So which functions have you converted down into machine code? Which functions are rejected or not allowed to be converted down to machine code. And there's a reason for that. We'll get into that later on in the video series. And then which functions are pending to be converted in machine code. So the JIT says, hey, I want to execute foo. Is it time for me to run it natively? And if it isn't, if it hasn't been generated, or for whatever the reason is no, it says, all right, just execute this on the interpreter. So then if you can imagine, there's an extra arrow here that goes back up to the interpreter and just continues interpreting that function. And that's kind of the flow. Now, if you wanted to execute it natively, what would happen is we'd talk to the JIT, it would then talk to the native code processor and say, oh, it looks like I have foo inside of my memory cache. Let me execute it here. It executes that function and then it comes back up and starts interpreting again. So, um, yeah, that's kind of the flow of it. But yeah, you can see here's the technical description of the JIT. Um, it's just basically something to make your language faster. All right, so we're almost towards the end of the video here. Now for the fun part. This is what I've been excited for. This is like the catalyst. This is exactly why I took a break for over a year. This is the straw that broke the camel's back, basically. So I'm going to summarize this paragraph. Basically, what I was doing was, as I was doing the video series, I was also doing stuff on the side. So I was trying to bootstrap the language, and I was doing some testing. I was doing some performance testing, and I basically wrote like the front end part of the compiler in the language itself. And you guys actually saw a video I showed you where I was showing you the tokenizer, the parser in the language itself, because I was so embarrassed to show you how shitty the code I wrote in the actual compiler for the language, because it was just so bad. So I, in short, wrote the front end part of the compiler, and I ran a test, and my God, was it slow. So here's a pre-development result. So it was so freaking slow, in fact, that I had to print this out on a piece of paper because I was just so I thought this was stupid. So basically, in short, I ran the tokenizer part of the compiler written in Sharp, and I started out by compiling, I'd say like maybe 300 or 400 lines of code, and that was cool, right? So that was pretty fast. And then, I cranked it up. I just went bananas. I said, all right, let me try 3,000 lines of code, right? Because typically in programming, if you're writing like enterprise software, you're going to have big files with big chunks of code. So this is going to be like somewhat of a real world example of what I can expect to, so that way I can see like how long the compile times are. And at this point, these pre-development results, this was before I wrote my JIT. This was before I did those performance gains where I dropped the size of objects and everything else that I did. This is purely before all the hard work that I've done in the past year. This is like before that. And it was so slow. I thought that like I was stuck in an infinite for loop. Like I got up, I went to the bathroom, I came back, and it was still running. And yeah, it was bad. So it eventually executed, and I was pretty upset. So I rigged together a very ghetto like profiler here. You can see Sharp Speed Profiler, and as you can see here, you can actually see the code that I'm executing. So you can see this was just the tokenizer, guys. Like I want you to realize how slow this language was at the time. This was just the tokenizer that I was running. It wasn't even the parser or even the backend side of the compiler. So the fact that it took 80 seconds to compile 3,000 lines of code, which is pretty bad. You can see it, here's the time, and it gives the average time per function call. So this is the average time it takes per function call. So 10 milliseconds to do a runtime.copy. I'm not going to talk about what that is, but you're basically just copying objects at the low level. This is a standard library function that gets called whenever you copy objects. And here's the tokenizer, here's advanced and other things. You can see like the file names here. This is really cool. This was a big help for me to kind of see like where the pain points are in my language, not only at the high level, but also at the low level, because everything's connected, right? So because I built my language from the ground up, from scratch, I can do whatever the hell I want. So this is one of those benefits of why I think building your own language from bare scratch is, I would advise you to do that because you can literally um, see, you can really get a grasp on what's going on. Now, I don't know if any of you guys ever noticed something wrong about this picture. There's something wrong here. But before I get into that, I want you guys to guess, how fast do you think I made this programming language? So I talked about a lot of stuff in this video, right? I talked about me doing tons of different things, adding new features. It took about 80 seconds or a minute and 20 seconds for me to compile 3,000 lines of code. I spent months revising the language, and I came back to it and I ran the test again, and I was blown away. So guess down in the comments below, how fast do you think I got it? All right, but here I'm going to talk about something that you guys may not have noticed. So if you look up here, it says total time, right? Now, my speed profiler is not perfect. What it tries to do is it tries to pick the top like functions that were like really, really important, like that were really long, right? It picks the top, was this, like 20 functions that were like the ones that took the longest in execution. But if you look here, the one that took the longest was 14 seconds. That's it. And then if you look at this one, it's 4 seconds, 4 seconds, and then these are milliseconds. So these are millisecond times. So it I don't know about you, but 14 plus 8 is not 80, right? That doesn't equate to 80. So there's something not adding up here, right? So I did some digging. What I found out was that a big reason why this was taking so freaking long is because of the size of my object. And that's really why I focused on scrunching them down so tiny, and squeeze them as tight as I could to like get them as compact as possible so that I didn't go through this, right? Um, so that was one. That was one reason. The second reason was the garbage collector. Because I was running this code, I was called. I mean, you can see some of these functions were called 100,000 times, 105,000 times, and so on and so forth. So I was creating hundreds of thousands of objects doing this. Not every function call create an object. Like for instance, here's std_string. This is a constructor for string. And you can see that was called 50,000 times. So we at least know in this block of code here, I created at least 50,000 string objects. So this is why I really like this compiler. But even if you add up all of these times in milliseconds, it doesn't add up to there. So another big update that I actually realized that I didn't add in the presentation before was I did update the garbage collector. Considering that we've never talked about the garbage collector, I decided not to add that as like an update because I mean, garbage collectors are a really complicated topic, and I don't want to like accelerate the complexity of this series too fast, so I tried to keep that out. I mean, I know JITs are like just as bad in terms of complexity, but I thought it was important because it had good context. But yeah, so I did upgrade the garbage collector a little bit, made it a little bit smarter, um, and did some really cool things to like um, speed it up, basically. So, all right, so let's get into what you guys have been waiting for. What is the fruit of my labor? So I didn't believe this. This is the post-development results. When I ran this the first time, I thought something was broken. I'm like, there's no freaking way. Like, I went from 80 seconds to 400 milliseconds. The same code. This is literally the same code. Like, look, you can see right here. So I was running my Sharp virtual machine, and I was running in the bin Sharp C, which is the Sharp compiler, which was compiled, which was bootstrapped, and then I was compiling test.helloworld.sharp. And as you can see here, it's about 3,000 lines of code, so 3,500. So I ran that same code, and this time I set a limit for I increased the limit for my garbage collector. This is one of those features that I added to my garbage collector to be able to modify the amount of memory it processes, and amongst other things. But yeah, you can see it took that quickly. So I was in denial. So I'm like, no, this is not happening. So what I did was I did a test, right? So if I don't know the technical term, I think it's called linear programming. But basically, the the phenomenon is in programming, if you have some bit of code, right, and you run that bit of code and it takes X time, If you then increase the work of what that code is doing by X, the time that it takes to execute should also go up by the factor of that same amount. So what I did was I then compiled 30,000 lines of code. And since it took, 400 milliseconds, it should take roughly 4 seconds to execute, um, because that's 10 times the amount that it's processing. I did that, and lo and behold, it did. Which I was even more shocked because I mean, I'm just looking at this, right? I went from processing 3,000 lines of code in 70 seconds to processing 30 plus thousand line file of code in like 4 seconds, which yeah, that's pretty crazy. But I still was in denial. I'm like, okay, I still don't believe it. This is not happening. So I went even further. I dug even deeper. So let's go back to this file, right? So we can see here it's about 31,670 lines. So we can see 31,670 lines. Now, this is Notepad++ that I'm using. Um, and Notepad++ also allows you to see how many characters are in the file. So you can see 766,000 characters. So I added, you can see in here in my tokenizer, at the bottom of the code, I added tokenizer's final process line is this. So here's how many lines I found. Tokenizer cursor location, that's how many characters I processed in the tokenizer. And then we can also see total elements found in file. Basically what that is like this is an element, this is an element. Basically how many tokens are in the file. So this is one, this is a like an identifier, this is a character, this is a string, so this is one element altogether. Here's another one, and so on and so forth. And lo and behold, I got the same result. I got tokenizer cursor, or how many characters I process, 7,600,000. I have how many lines, 31,670, same thing. And this doesn't mean anything. Elements found, I was just curious to see how many elements are in the file. There's no way I can get that data from here because, yeah. But yeah, no, this was the final proof that showed the fruits of my labor have paid off. And in fact, it's actually a little bit faster than when I ran it before. And I ran all of this like one after the other because I was just like, there's no way. So yeah, uh, thank you guys. Thank you so much for sticking with me. I know it's been quite a long road. It's it's been crazy, and your boy's been busy. I've done quite a bit of work to like improve this language and make it something amazing. Something that I know that you guys would be very excited for to see. My goal with this channel is I want to be that channel that everybody goes to when they want to learn how to build a programming language. I want to be that channel that professors use as a reference to like as a guide to show you how to build certain parts of a compiler and so on and so forth. So I just want to thank you guys for coming back and watching my videos. And from now on, moving forward, this is it. Like the series is not going to stop. Like there's not going to be any more breaks. There's not going to be any more hiatuses. I'm going to be more consistent, uploading a video every single week, um, because there's no reason for me to not, like, I don't have an excuse anymore to not put out a video because I'm actually proud of the product that I'm putting out there for you guys and showing you actually how to build a programming language the right way. So hope you guys enjoyed the video. It's been a long one. And like I said again, thanks for coming back. Definitely like and subscribe if you guys like what you saw and you want to see more. Until next time, I'll see you guys later.